Hey guys, and welcome back to another lesson on probability. But I hope you got your thinking caps on because this is not your typical introduction to probability lesson. These are the hard questions. So we're not just sponging up information here, we're really putting our mathematical knowledge and understanding to work. My name is Miss Danielson, and let's get started. Before we get started, I should probably warn you that this lesson, unlike most of my lessons, does not involve a practice exercise at the end. So please take advantage of any opportunity you have to hit pause and try these questions for yourself before we go through them together. So for example number 1, a bag contains 60 beads, while X of those beads are red and the rest are green. Olaf takes a random bead from the bag. State in terms of X the probability that Olaf took a red bead. Now, this is kind of a gift as a question. It might be one of the first few questions on an exam because it doesn't require much work. If there are X red beads and there are 60 beads altogether, the probability of choosing a red bead is X out of 60. Now, that must be written as a fraction, not in words, because the answer is not X, it is X divided by 60, whatever that value may be. And since we're stating our answer in terms of X, we don't need to work out what that value is. We simply need to write an expression with the letter X in it. I'm hoping that question was a bit easy for you, so let's step it up a bit. Olaf puts his bead back in the bag, and another 20 red beads are added to those already in the bag. The probability that Olaf takes a red bead is now doubled. Use this information to write down an equation at X, and show that your equation can be expressed as 8x equals 3 bracket x plus 20. Now this question is quite a bit more challenging. However, they're giving us a big help here by telling us the answer. We just need to work this through and show all of our working to arrive to this answer. Think about the information we already know. We knew that there were 60 beads in the bag, and X of those beads were red. Now we have 20 more red beads and 20 more beads altogether in the bag. So we could say that the new probability of choosing a red bead would be X plus 20, that's the new number of red beads, out of 60 plus 20, that's the new total number of beads that there are. And we know that this new probability for choosing a red bead is twice the previous probability of choosing a red bead. Now this is very easy to confuse. If the new probability is twice the old probability, we don't need to multiply the new probability by 2. This is already 2 times this probability. So we can say that the new probability is equal to 2 times the old probability for choosing a red. And substituting in our expressions for each of these probabilities, we can say that X plus 20 over 60 plus 20 is equal to 2 times X over 60. That's 2x over 60. Now, a little bit of familiarity with fractions is necessary here. If we're going to multiply 2 by some fraction, we only need to multiply it by the numerator, not by the numerator and denominator, because that would just give you an equivalent fraction. That would be like we didn't multiply it by anything at all. Now we just need to simplify both sides of this equation. X plus 20 over 60 plus 20, well, we can add 60 plus 20, that's 80. And 2x over 60, we can simplify that fraction by dividing both the numerator and denominator by 2, leaving us with x as the numerator and 30 as the denominator. So we've got an equation now. Well done, right? We got it. Olaf, something doesn't quite look right here. Our equation needs to be in the format that they gave us in the question. And our equation here has fractions in it. So what are we going to do? Don't worry, fractions are just divisions. So if we want to get rid of these fractions, we just need to take the denominator of the fraction to the other side of the equation and multiply it. So I've taken my 30 from the bottom of this fraction over to this side, and I've multiplied it by the x plus 20. And I've put that in brackets to show that the 30 is multiplying by everything here. And I've taken my 80 from the denominator, and I've multiplied it across by the x on the other side of the equation. So that's 80x. Now this is looking a lot better. Compare that to the answer that I need to get. I've got something multiplied by some bracket, and I even have the correct terms inside the bracket. But what I need out front is 3, not 30. And the other side of this equation is some number of x, but I need it to be 8x, not 80x. So hopefully looking at the format that you're trying to get, you can see what you need to do to your equation. You should have noticed that both sides of your equation can be divided by 10. 30 divided by 10 would give me the 3 that I'm looking for, and 80 divided by 10 would give me the 8 that I'm looking for. So we've got 3 bracket x plus 20 is equal to 8x. Now that's the same equation as we were given in the question. So long as you show all steps of your working, you know that you got that right. So sure, why not celebrate with a snow angel? But we're not quite done just yet, Olaf. Part BII asks us to solve the equation 8x equals 3 bracket x plus 20 and show you're working clearly. Now, the thing I love about these questions, even if you couldn't find the equation given in part BI, they gave it to us so that we could work through it in part BII. So we've already got the equation 8x equals 3 bracket x plus 20. We just need to solve it. And make sure you show you're working clearly. Don't try and show off and do this without showing working. The examiner will not be impressed. You need to show all steps of working. So hopefully you notice if we want to solve this equation, we need to get x on its own. But I've got two x terms in this equation. I've got this 8x here, and I've got this x which is trapped inside a bracket. So my first step should be to expand that bracket out. Multiply the 3 by all the terms inside the brackets. So I've got 8x is equal to 3 times x, 3x, plus 3 times 20 is 60. Now I've got an equation with two terms, which both involve x, but they're on opposite sides of the equation, so let's get them together. My general rule of thumb is try to move the smaller x term. As 3x has a smaller coefficient than 8x, I'll move the 3x over to the left-hand side. Over here, the 3x is adding with the 60, so I'm going to subtract it from the other side. So I've got 8x minus 3x equals 60. Simplifying that, 8x minus 3x is 5x. Now I need to get the x on its own. The 5 is what's bothering me here. Let's get rid of it. It's multiplying by the x, so let's take it to the other side and do the opposite. 60 divided by 5. So x equals 12. And yes, Olaf, we've come to the end of the question, and I know you're ready to celebrate, but let's have a think about this answer. What is x? Remember, x was the number of red beads that Olaf started with. So it shouldn't be a negative or a decimal value, which it's not. So yes, it does make sense for it to be 12. But let's take this one step further to check that this is actually the correct answer. Olaf started with 60 beads, right? And now we're saying that he had 12 red beads. And the rest, which is 48, would be green beads. So in part A, we worked out the probability he chose a red bead was x over 60, in this case 12 over 60, which simplifies to 1/5. And then when 20 more red beads were added, he would have had 12 plus 20, that's 32 red beads. Out of 60 plus 20, that's 80 beads altogether. Now this probability simplifies to 2/5, dividing both top and bottom by 16. Notice our two probabilities for choosing a red bead. The original probability was 1 out of 5. The new probability is 2 over 5. And the new probability for choosing a red bead is twice the old probability for choosing a red bead. So yes, now we can celebrate. You don't need to do a check every single time, but look how good it feels when you know that you're right. Now on to example 2, which may seem a bit intimidating at first, particularly because of the set builder notation we've got here. But don't worry, I'll talk you through it. A set of n counters, now n represents some number of counters, are each numbered with a different value from a set of values x. Now here I'm defining what x is, and again, x has some value. X is greater than or equal to 1, but less than or equal to n. And x is a member of these types of numbers. Now this capital N represents natural numbers. Those are whole positive numbers. And n is an even number. Work out the value of n if the probability of randomly taking two even counters from the bag without replacement is 5 over 22. Now, I emphasize without replacement because what that means is when I take a counter out of the bag, I don't put it back into the bag. So the next time I go into that bag to pull out another counter, there are fewer counters to choose from. Go ahead and try that for yourself if you feel ready for it, or allow me to talk you through this a little bit more. If I'm talking about n counters, all numbered with a different value between 1 and n, where all of these numbers are positive whole numbers, here's what my counters might look like. 1, 2, 3, 4, and I don't know how many of them there are. However, I'm told that there is an even number of counters. So think about how that's going to affect my answer. Work out the value of n if the probability of taking 2 even counters from the bag without replacement is 5/22. 2 even counters. Think about how many even counters there would be. If there were an odd number of counters, like 3 for example, there would be 1 even and 2 odds. But since there's an even number of counters, like 4 for example, there would be the same number of evens as there are odds. So we could say half of these counters are even, at least to begin with. But when we start taking even counters out of the bag, we'll start having fewer even numbers left in the bag than there are odd ones. So let's start setting up the probability of randomly taking 2 even counters. The probability that you take an even counter and take another even counter, because these are independent events, we multiply their probabilities together. The probability that the first counter we take out of the bag is even is the number of even numbers in the bag out of the total number of counters in the bag. We said that there was just as many even numbers as odd numbers because there's an even number of counters in the bag. Half of those counters are even out of the total number of counters in the bag. Now, it might have been easier for me to simply say that the probability of choosing an even counter is a half. However, I wanted to write it this way so that you could see what happens when I've already taken out one of these counters. If I took out one of those even counters, there would be one fewer even numbered counter, but there's also one fewer counter altogether in the bag. So this is now the probability that I take out a second even counter. There were fewer to choose from, and there were fewer in total. Now, simplifying these fractions, as I said before, the probability that the first counter was even is a half. And to make this simpler, n divided by 2 would be half of n, or 0.5n. If we multiply these two fractions together, we multiply our numerators together, so 1 times 0.5n minus 1, and we multiply the denominators together, so 2 times n minus 1. The top has not changed because multiplying by 1 won't change its value. However, the bottom, both terms have been multiplied by 2, so 2n minus 2. And now supposedly, this is equal to 5/22. So let's solve this equation to find out how many counters there were. Now, if you're like my students, you probably get a bit nervous with fractions, but again, don't be afraid. Fractions are just divisions. To undo them, we multiply the denominators across. So this denominator here of 2n minus 2, we'll take it over to the other side and we'll multiply it by the numerator. And this denominator here, the 22, we'll take it to the other side and multiply it by the numerator. Remember to use brackets to ensure that you're multiplying all terms by the expression that you've just brought across. Expanding that out, we'll do 22 times 0.5n, that's half of 22, 11n. And 22 times negative 1 is negative 22. Then we've got 5 times 2n, 5 times 2 is 10, so 10n. And then 5 times negative 2 is negative 10. Now to solve this equation where we've got n on both sides, we want to get the n's to the same side. Again, remember our rule of thumb is to move the smaller variable term. 10n has got a smaller coefficient than 11n, so I'll move the 10n from this side over to that side. But be very careful with the signs here. That minus belongs to the 10, so I'm leaving negative 10 on the right-hand side of my equation. This 10n is positive, so I'll subtract it over to the other side. And to keep my n's on one side and my numbers on the other, I'll take this negative 22 and I'll add it across to the other side. So I've got 11n minus this 10n equals negative 10 plus this 22 has come across. Simplifying that, 11n take away 10n is simply 1n or n, and negative 10 plus 22 gave us 12. So n is equal to 12. Let's just check to make sure that that answer makes sense and is correct. If n is equal to 12, there were 12 counters to begin with, and the probability of choosing the first even counter would have been half of that. 6 out of 12 would have been even. But if I took one of those even numbers out of the bag, I would be left with 5 even numbered counters. And instead of having 12 counters altogether, I would have 11 counters left over. If I multiply that through numerator times numerator, 6 times 5 is 30, and denominator times denominator, 12 times 11 is 132, I get 30 over 132, which is not 5 over 22. However, this obviously can be simplified. 30 and 132 can both be divided by 6, and that gives me the 5 over 22. So again, although it's not always necessary to do the check, it definitely is gratifying to see that your answer does make sense. So well done. Example 3 will be our last example for this lesson. It's also our most challenging. So let's talk it through. A bag contains X counters. 7 of those counters are blue. Bob takes a random counter from the bag and does not replace it. Remember what that means. Patrick then takes a counter from the bag, and the probability that they both take a blue counter is 0.2. Remember, probability could be a decimal value or a fractional value. 0.2 is equivalent to 2/10 or 1/5. Part A, form an equation involving X. My equation must have something to do with the probability of both taking a blue counter being equal to the 0.2 we're told above. Show that your equation can be expressed as x squared minus x minus 210 equals 0. Now, this equation doesn't look at all like something equals 0.2, but this is the final format I need my answer to be in. And again, I love these questions because if you get your answer to that format, you know it's right. Also, for part B, we need to calculate the value of x. And if you weren't able to solve part A, you weren't able to find the equation x squared minus x minus 210 equals 0, you still have that equation that you can use to solve to get the marks for part B. But let's give part A a go. Again, remember, you can always hit pause and try it for yourself first. If you get stuck, hit play and I'll talk you through it. First of all, let's set out the equation where the probability that both Bob picks a blue and Patrick picks a blue is 0.2. The probability that both of these events occur, since they are independent events, will be the product of the probability that each of these events occur. So, probability that Bob picks a blue multiplied by the probability that Patrick picks a blue has to be equal to 0.2. Now let's write an expression in terms of x that Bob picks a blue. There are x counters and 7 of them are blue. So Bob has a 7 out of x chance of picking a blue, while Patrick is the second one to pick from the bag, and Bob has already taken one of those blue counters out. So there's only 6 blue counters left. So Patrick has a probability of 6 over x minus 1 of picking a blue counter. Now x minus 1 because we've taken one of the counters out. If we multiply these two fractions together, we simply multiply our numerators together and multiply our denominators together. So we get 6 times 7 as our numerator, and x times, use brackets here to make sure you're multiplying by both terms in the denominator, x times x minus 1. So we've got 42 over x squared minus x equals 0.2. We've got an equation, but it's not quite in the right format. First of all, we've got this fraction here to worry about, but I'm hoping we're not worrying about fractions anymore because fractions are just divisions. To get rid of the fraction, simply take the denominator to the other side and multiply. Multiplying this through, 0.2 times x squared is 0.2x squared, and 0.2 times negative x will simply be negative 0.2x. And while I'm at it, I've taken my 42 from this side over to the other side. As you can see, I want my answer in the format where it's a quadratic equal to 0. So now I've got 0 equals 0.2x squared minus 0.2x minus 42. This is not quite the correct format just yet. I need this just to be x squared, not 0.2x squared. As I mentioned before, our probability was given as a decimal, but this decimal is equivalent to the fraction 2 in the tenths position. That's 2/10, or 1/5 since it simplifies down. If this is 1/5 of x squared, if I multiply everything here through by 5, and I do mean everything, I'll do 0 times 5, which is still 0, and 0.2x squared times 5 will give me x squared. 1/5 times 5 gives us 1 whole x squared. So I then have x squared, I've got negative x, and I've got minus 210. So as you can see, Bob and Patrick are pretty happy about that. Our answer matches the answer given in the question. Well done, guys. On to part B. Even if we couldn't find the equation in part A, we can solve that equation to find the value of x. But notice that this is a quadratic. We don't solve quadratics by getting x on its own. You can either use a formula or you can factorize. Think of a number that multiplies to make negative 210 and adds to make negative 1. Remember, if there's no coefficient, no number in front of the x term, that number is 1. The numbers that multiply to make negative 210 and add to make negative 1 are negative 15 and positive 14. 15 times 14 makes 210, but one of them must be negative if we're going to multiply to make a negative answer. And these two numbers, which need to add to make a negative number, the bigger absolute value must be the negative 1. Negative 15 plus 14 would still be negative 1. Whereas if I had the signs reversed, positive 15 minus 14 would be positive 1. So I've got that correctly factorized. However, to solve a quadratic, we need to consider that this expression multiplied by this expression equals 0. So either the expression in this bracket must be equal to 0, or the expression in that bracket must be equal to 0. So either x minus 15 is equal to 0, or x plus 14 is equal to 0. If x minus 15 equals 0, that means that x is equal to 15. If x plus 14 is equal to 0, that means that x is equal to negative 14. So we've got two answers for x. So which one's the right one? Remember what x represents. X is the number of counters, so it should not be a negative value or a decimal value. So that helps us to discard this answer here. X could not be negative 14. It must be this 15 here. But is 15 right? Let's check this through. If there were 15 counters in the beginning, remember we were told that the probability that both counters were blue was equal to 0.2. And we worked through to this equation by saying Bob's probability of choosing a blue was 7 out of x, and Patrick's probability of choosing a blue was 6 out of x minus 1. So substituting 15 in for x here, we can say that 7 over 15 times 6 over 14 must be equal to 0.2. Now, is that true? Multiplying these fractions together, I get 42 over 210, and 42 divided by 210 is 0.2. Yes, Bob, you are a mathematical beast. Well done. Did you manage to get that on your own? Please let me know down in the comment section if you had any difficulties or if you found this a bit confusing. Otherwise, keep practicing, and I'll see you soon. Thanks for watching, guys.